data communication, and computer networks. Multiple access control.
So today we are going to start Dcn third unit. Okay. So Dcn third unit we will be covering the next CA. Next CA is Dcn third unit and fourth unit will be there. That is where. So unit 3 we are going to start with multiple access control. So what is multiple access? Multiple access
more than one
or two
access.
It may be a device or it may be any network hardware. It can be anything, right? So multiple access is going to be done. So multiple access is the mode how we are controlling is multiple access control. So it comes under Dcn where we have to communicate that data is going to be passed. So data we pass pannaporum. Obviously more than one device is going to be there. So more than one device is what will happen? More than one device is
More than one.
More than one or two devices there, what will happen? Connections has to be made, right? So dedicated link should be there or undirected link should be there, right? So dedicated link na in the device pass on that should be there. So no dedicated links means no connections will be there, right? So that has to be maintained and controlled. So for that we are going to control the data, okay? So if you are not controlling the data, what will happen? It will get collided. So data will be lost item, it will not reach the destination at the proper time, right? So that is the multiple access control we are going to see about. Multiple access control is a very important topic we have to see, right? So that is there will be a dedicated link between the sender and receiver. We know what is the sender, receiver, right? So sender is the data send panna poranga, receiver will be the destination where they are going to receive the data, right? So sender ko receiver ko naduvula nam enna pandrom transmission medium message we are passing the data. So that and all we have seen in the unit 1 itself, right? So we are going to pass the same set of data but in a multiple access. That is the important point we have to note it. So however, if there is no dedicated link, so no dedicated link means as I told there will not be a directed links. Directed means it will be connected using the wires or the devices will be fixed. So no dedicated links means it will not be fixed, it will not be connected. So just like that it has to pass through. So how the destination will be found is nothing but by the means of IP address, right? So using that receiver or IP address data will be passed to the destination, okay? So hence multiple access protocols are required. So why we require is nothing but to reduce the congestion, to reduce the data loss and to receive the data in a proper destination, right? So all these things are the important concept we are going to see. So note it down, multiple access protocol, you have to note all these things. We have to explain in brief about all these things when we get into the multiple access protocol. So multiple access protocol is again divided into 3 types. Note panningo, everyone should have noted. So multiple access protocol, random access, controlled access, channelization protocol. So these are the 3 divisions of multiple access protocol. So random access again is subdivided. Alloga, CSMA, CSMA-CD, CSMA-CA. Okay. So then again when we come to the controlled access protocol, it is again divided into 3 types: reservation, tuning, token passing. Okay. Channelization like FDMA, TDMA, CDMA. So these are the subdivisions of each and every access controls. Okay. So have you all noted? Where you have noted? What one? Okay. So the first type is random access protocol. So what is random access? Random, what do you mean about random? Unknown data. எங்க இருக்கும்னு தெரியாது. We are just bringing up. So suppose 1 to 10 இருக்குன்னா there is no fixed access or there is no fixed protocols to be followed. It will just go like that and pick up any one protocol or any one destination. சரியா? So random access protocol is nothing but all stations have same superiority. What is superiority? What is mean by superiority? Which is of most important is the superiority, right? So it will not be having that priority process. So if there is a priority, we will be fixing that which is going to be the first device or which is going to be the first destination, right? So since there is no superiority, we can have a random access. Okay, so all stations have same superiority, that is no station has more priority than any other station. So which means there is no priority. So priority இல்லாதனால என்ன பண்றோம்? We are randomly accessing the device. So device is nothing there. Can be a system or it can be the destination where it is going to be this time, right? So it will be of no protocols will be fixed here. It will be of random access. Okay. So there is no schedule time since there is no device or fixed. There is no fixed link, fixed path. So we are just like that. It is going to be passed through, right? So no fixed path will be there. It will be accessing as random. So random access la போகறதுனால it will not be fixed any destination. So destination இல்லாதனால என்ன பண்ண முடியாது? டைமும் நம்ம fix பண்ண முடியாது. So how long it will take to reach it, we cannot fix it, right? So that is no schedule time will be fixed when we transmit the data from sender to the receiver. Okay. So what it will do is any station can send data depending on medium state. So it will be checking that medium or state check பண்ணோம் whether it is idle or busy. So idle na என்ன அர்த்தம்? What is idle? Doing no work. So எந்த CPU-மே எந்த work-ம் பண்ணாம just it is idle. So that is a no work situation. Busy na ஏதோ process உள்ள run ஆயிட்டு இருக்குன்னு அர்த்தம், right? So it will be sensing whether it is idle or busy. So idle irukna it will pass through the data or busy irukna it will be waited. Okay. So that is we have to sense the data. Sense the medium status whether the data is processing there or it is in idle status. Right. So since that is the case, there is no fixed time. There is no fixed sequence of stations. We are not deciding the destination, right? So அதனால fixed sequence கிடையாது, timing-ம் கிடையாது. So that will be the case in random access. So this has been solved or this has been again subdivided into the other four types which you have seen in the before slide, right? So Haloga, CSMA, CSMA CD, CSMA CA. Okay. So then single. So if you are writing about random access protocol, you have to write the four subtypes also. Haloga, CSMA, CSMA CD, CSMA CA. Okay. So you see the Haloga alone. So Haloga is nothing but the medium is shared between the stations. So here the station is nothing but the devices. So station is சொல்லலாம், device is சொல்லலாம், or the sender, destination, source, destination can be whatever, right? So medium is சொன்னாலும் ஒண்ணுதான், station சொன்னாலும் ஒண்ணுதான், okay? So the medium, station சொன்னாலும் ஒண்ணுதான், device சொன்னாலும் ஒண்ணுதான், okay? So we are just passing the data through that transmission medium to the devices, right? So when we are Haloga, there will be of multiple stations. Multiple stations is nothing but so station A இருக்கு. So station A is there. It can pass through any devices, right? So B, C, D இந்த மாதிரி என்ன device இருந்தாலும் multiple access தான். More than one station is there or more than one device is there means that is nothing but multiple access, right? So here we are considering the multiple access only. So multiple stations will be there. At the same time, it will be transmitting the data to all the multiple stations as you see there, right? So A the sender என்ன பண்ணும் data prepare ஆனதுக்கு அப்புறம் B, C, D all the devices will be transmitted at the same time, right? So it will be sending the data. After sending, what it makes is it will receive some acknowledgement. What is acknowledgement? Receive பண்ணிட்டேன்னு சொல்லிட்டு I am giving a reply, right? So இப்போ நம்ம WhatsApp என்ன பண்றோம்? We are maintaining, we start post some content. What you people do? நான் அதை read பண்ணிட்டேன் அப்படின்னு இல்ல submit பண்ணிட்டேன். You are giving some acknowledgement reply, right? So like the same, sender A is going to send the data. B, C, D after receiving the data, it is asked to what? Give some acknowledgement. Okay. So return line integer, it has to receive that acknowledgement. So for that acknowledgement, sender will be waiting. Okay va? So acknowledgement 1 da mattumna what the sender will do? Again send the next packet of data. So until that it has to wait, it will not transmit any other next data. Okay. So if the acknowledgement doesn't come, so acknowledgement varala appadina what it means? Data has been lost, right? So data வந்து receiver கிட்ட போல. So it means data has been lost in between, data is not received at the destination. So what it will do is again retransmit the data. So again it will be retransmitting the same set of data until the positive acknowledgement has been received. Okay. So if it is receiving the positive acknowledgement, what it does is it will again send the next set of data. Okay. So for receiving that acknowledgement, it will be having a back of time. That is TB. Back of time is a TB. Okay. So what that TB is nothing but after sending the data in the time kulla with acknowledgement vanduchna it is being positive. And the time kulla acknowledgement varlana it has been lost in between, so it has to retransmit again, right? So that is the condition here. So one more thing we have to note that there is a vulnerable time. So vulnerable time is nothing but possibility of collisions. So when the collisions will occur? When the collisions will be occurring? When two of the data gets collapsed, it will be collided, the data will be lost in between itself, right? So that time or that possibility is considered as a vulnerable time. Okay? So that is possibility of collisions, will be calling it as a vulnerable time. So that will be calculated in the pure algebra by the means of 2 into that transmission time. So frame transmission is a DFR. DFR is nothing but frame transmission. 2 into the transmission time will be the vulnerable time. Okay? So for algebra we have to calculate like this. So algebra, pure algebra we have seen. Next one more algebra is there, that is slotted algebra. So we'll start with this. Okay. So algebra, slotted algebra will be there. What we have in the pure algebra is nothing but it will be waiting for the back of time to get the acknowledgement, right? So as a pure algebra we have seen. But slotted algebra is nothing but it will be divided into the time slots. The time slot na for 5 seconds time will be fixed. So sender has to send the data, receiver has to receive some data and reply it has to give the acknowledgement, right? So the time ellame and 5 seconds kulla mudiyanum. So that is a slotted time. Okay. So it will be giving that slot time for each and every station to transmit. So suppose this is A mara extra. So A, B, C, இந்த மாதிரி இருக்கும். Okay. So A will be adding once 5 seconds. Next 5 seconds the B will be transmitting. Next 5 seconds C will be transmitting, right? So like the same, it will be allocating the time for each and every station whenever it has been scheduled. That is slotted algebra. It will be divided into time slots. Okay. So it is similar to the pure algebra only, but only one difference is we are dividing the time. So for each and every station, the time will be divided into slots. So each and every slot, varumbodhu mattum enna panna mudiyum, station can transmit the data. So if it misses that station, adoda time slot miss aidichna, again it has to wait to get the time slot again. Aditya. So if it misses the time slot, it has to wait again to get the time slot for that station. Okay. So the time slot will cross aidichna, there is no problem. If it is not getting or if it is not getting started at the time slot, it has to wait for the assigning of that time slot. Okay. So that will be the slotted algebra. Here the slotted algebra vulnerability will be taking TFR. TFR na enna sonna? What is TFR? Transmission, frame transmission, right? So the pure algebra irukkumbodhu 2 into the transmission time. Slotted algebra it will be transmitting the same transmission time will be the vulnerable time. What is the vulnerable? Vulnerable time enna paakom? What is that? Possibility of getting collision, right? So collision ஆகுதா இல்லையான்னு கண்டுபிடிக்கனா we are using the vulnerable type. Okay. So these two we have to write in the halogen concept. So just நம்ம என்ன முடிச்சிட்டோம்னா so we have known about what is multiple access protocol, random access னா என்னன்னு பார்த்திருக்கோம். In that halogen we have seen halogen again it is divided into two types, pure halogen and slotted halogen, right? So up to this we have completed. So this remaining we will continue in the next class.